Welcome back to Algebra 1. This is lesson 5-11, and it's using different methods or elements of factoring. Now, first thing that people always forget to do when they're factoring, and it just makes the problem harder, okay, is to take out the greatest common factor. So let's look at this one right here. We notice all of our coefficients end in a 0. That means we can factor out a 10 right off the bat from everything. Okay? And what that does is to make our other numbers, our other coefficients, so much smaller. All right, now, the next thing we notice, we need to look at our variables. So not only can we factor out a 10, I'm going to move the 10 over a little bit here. What we can also factor out, there's an A here, an A here, an A here, and an A here, at least one in each spot. So we can factor out an A. So we have 10A, and then we have A squared minus 2AB plus 3A minus 6AB. So we took out an A. Right? Now it's going to be a matter of grouping. And we have an A squared and an AB term here. Well, and this should be just a B here. Sorry. Let's fix that, because if we take the A out of here, there's just a B left. Okay. So we have an A squared term and we have an AB term. The next thing we ought to look for is to see if we have a B squared term anywhere. And we don't, because then we would make a trinomial, A squared plus AB plus B squared, but we don't have a B squared anywhere. So let's try grouping this way. Let's group those two together, and because this is a plus, not a minus, I can go ahead and insert my parentheses there without changing anybody's sign. So now let's see if we can factor right here. I can take an A out of here, so we still have our 10A out on the side here. I can take an A out of here, and I'm left with A minus 2B. Okay, that's what's in this parentheses. Plus, I can take an A, or actually take a 3 out of there. 3 out of 3A leaves me with just an A. 3 out of minus 6B leaves me with a 2B. Okay? So we factored this by pulling out an A. Factored this by pulling out a 3. Now my eyeballs should be saying, oh, looky, 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 looky. Looky, 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 looky. I've got two factors that are exactly the same. So I have my 10A out here. Still have my A right there, and I'm going to factor out, actually, take what's common, the A minus 2B. That's the common factor. And what's left, I'm going to put in another set of parentheses. A plus 3. Okay? Now, since it's all multiplies here, and I don't have any minuses or pluses in between, I can get rid of this outer set of parentheses. Okay? And my answer is 10A times A minus 2B, excuse me, times A plus 3. All right, let's try another one. Over here, again, look for the monomial, a number and or a variable that you can pull out first. You can factor out first to make things smaller. Well, if I look, I've got a 25 here and a 25 here. So I can factor out a 25, and I'm left with m to the 8th minus n to the 8th. Now, here we go. Difference of two perfect squares. Okay, so I'm going to break that up into m to the 4th plus n to the fourth times m to the fourth minus n to the fourth. Now, the mistake that people make here is to stop too soon, because here's the difference of another set of perfect squares. So we have to keep going. We have to take this part right here and break it into m squared plus n squared times m squared minus n squared, and again, we're still not done. We have to take this part and break it into m plus n times m minus n. So my final answer is going to be 25 times m to the fourth plus n to the fourth times m squared plus n squared times m plus n times n minus n. Right? So when you start breaking up the difference of two perfect squares here, it's going to take a while to sort of factor your way down. Okay? Now let's look at problem number 3 here. Problem number 3, if you'll use what I call substitution for a minute, it'll make this problem a lot simpler. Okay? Let's say that out here we're going to say a plus b, or a plus b equals capital A. We're going to replace it with a capital A just to make the number of letters, okay, and the visual clutter a little bit better here. Well, if I do that, then here's my a plus b. What I've got is a capital A cubed minus 6 times a squared minus 7a. Okay? And that's a lot simpler looking. Now I can factor a capital A out of each of these. So now I have a times a squared minus 6a minus 7. Okay? Now that, come over here, that we can factor using our regular factoring method. Okay? And we have, so we have capital A times a squared minus 6a minus 7. Okay, we're looking for two special numbers that when I multiply them together, I get negative 7. And when I add them together, I get negative 6. Well, that's going to be a negative 7 times a positive 1, because a negative 7 plus a positive 1 gives me a negative 6. So this is going to factor into a minus 7 times a plus 1. Now I'm almost done, except I need to plug back in for the capital A, because remember I substituted it originally for the little a plus b. So wherever I have a capital A, I need to put back a plus b. Okay, all I've done is substitute back the other way. And then I can get rid of some parentheses there. Since there's not a minus in front out here, I can use a plus b minus 7. Same thing here, a plus b plus 1. Okay? So sometimes when you have a problem that's really cluttered looking, choose another letter to represent some of your symbols. And that'll make it easier to see what to do with the problem.